Hello students, hope you are doing well. In this video we'll look into the next part of laws of motion, and that part is friction. Now what is this friction? Friction is a force which opposes relative motion between two surfaces in contact, or the tendency of relative motion between two surfaces in contact. So let's take an example, where you are trying to push a heavy box and the box is not moving. Now, if the box is not moving, it is in equilibrium. So if it is in equilibrium, the net force should be zero. So which force is balancing your force? The frictional force acting between the box and the floor. So there it is opposing tendency of motion. Now let me take another situation where I push a small box where the box is moving. So again, when you're pushing, why it is difficult to push the box, because there is frictional force which is opposing the motion. So there it is opposing the motion. So frictional force can oppose tendency of motion, as in first case when the box was not moving, or it can oppose relative motion between two surfaces in contact. But what is necessary is that two surfaces should be in contact. If the surfaces are not in contact, then friction doesn't come into picture. Now the factors on which friction depends is, one of the factors on which friction depends is the nature of surfaces in contact. So factors affecting friction are nature of surfaces in contact. If the surfaces are rough, then friction would be more. If the surfaces are less, the friction is less. That is denoted by coefficient of friction between the two surfaces. And the second thing on which the friction depends is on normal reaction. How you know how much force is pressing the body with the surface. If the pressing force is more, normal reaction is more, and frictional force is more. And one important thing that you have to remember is friction does not depend on area of contact. So friction does not depend on area of contact. So that means, you have a big box, you put it on the flatter surface or the thinner surface, whatever surface you put it, the frictional force that is going to come into existence is going to be same. Now let's try to analyze this concept of static friction and kinetic friction. If I keep on, again, I'll just take the example of box, a heavy box which I was pushing and the box was not moving. So what I did, I asked one more person to join. He also pushed. Still the box didn't move. Again, I asked some more persons to join. They also pushed. Still didn't move. After 10 people came, the box started moving. So what is happening till the box is starting to move? The friction when no force was applied was zero. Now first case only one person is applying force. Let's say friction is equal to force applied by one person. Second case when two persons were applying force, the box was not moving. Friction applied was force applied by 2%. Third case, 3 persons, friction applied was force applied by 3% because it is not moving. 9 persons also, it is not moving, friction applied is 9 times the person. Now after 10th person came, body starts moving. Then after that, what is happening? The friction remains constant. So we can see that with increase in applied force, friction is also increasing. So if I draw a graph between frictional force and applied force, I get a straight line which is linearly increasing, right? So till here, till the body doesn't move, this part is called static friction. So what is static friction? Friction between two surfaces in contact when there is no relative motion. Now static friction can be anything between 0 and maximum value. And this maximum value, it is called limiting friction or limiting static friction. Now why is it called limiting static friction? Because the frictional force between the two objects cannot be greater than that. And static friction can have any value between 0 and limiting friction. After the body starts moving, the friction slightly decreases and it becomes constant, and that is called kinetic friction. So let's try to find out what is static friction. Static friction is directly proportional to normal reaction. Limiting friction is directly proportional to normal reaction, or limiting friction is given by mu s into n. So this is the expression for limiting friction, where mu s is coefficient of static friction. So what is mu s? Mu s is coefficient of static friction, right? Now similarly, if I want to write it for kinetic friction, I write Fk equal to mu k into n, where mu k is what? Mu k is coefficient of kinetic friction. Mu k is coefficient of kinetic friction. So these are the formulas that we use for finding friction between the surfaces and objects. Now let's look at contact forces and angle of friction. Now what are contact forces? A force that requires contact between two surfaces to come into existence is known as contact force. Now what are the contact forces that are acting on a body which is placed on an object? The only two contact forces that we have are normal reaction and frictional force. Normal reaction always acts perpendicular to the surfaces in contact. You can see that in the figure. Normal reaction is always acting perpendicular to the surface in contact, and frictional force is acting parallel to the surface in contact. Now here R is the net contact force. So if I write frictional force as F, then I can write net or resultant contact force equal to under root of n square plus F square. Now what do we know? F equal to how much? Mu into n. So I can write net contact force equal to under root of n square plus mu into n whole square. So I can take out n outside. I'll be left with under root of 1 plus mu square. This is the net contact force that is experienced by the surface or applied by the surface on the object. Now this angle theta is defined as angle of friction. So how do I define angle of friction? The angle between the net contact force and the normal reaction is known as angle of friction. So this is what is angle of friction, theta. So angle of friction is what? Angle between the net contact force and the normal reaction. Now let's look at friction under various cases. Friction on horizontal surface. So what is frictional force? In horizontal case, what will happen? What is normal reaction? Normal reaction is mg. So because normal reaction is mg and limiting friction would be equal to how much? Mu s into mg. And kinetic friction would be equal to how much? Mu k into mg, because n equal to mg. Now if the body is moving, what is the acceleration of the body? So if a force F is applied on this, then the acceleration of the body can be written as F minus mu k into mg by m. Here we are using mu k because if the body is moving, then the friction that is coming into picture is kinetic friction. And if the body does not move, I don't have to do anything. I can say frictional force equal to applied force. So under what condition a body does not move? If applied force is less than or equal to limiting friction, body does not move, or this is a static case. So that means let's assume that limiting friction is some 100 Newton. So if I'm applying any force less than or equal to 100 Newton, then it is static. So that means if applied force is, let's say, 20 Newton, then frictional force would also be equal to 20 Newton. Applied force is 30 Newton, then frictional force would also be equal to 30 Newton. That means what? Till the applied force is less than or equal to limiting friction, applied force would be equal to frictional force. Now let's look at a situation where a force is applied at an angle theta. When a force is applied at an angle theta, then there are components of forces. This is F cos theta and this is F sin theta. Then what will be the friction here? Friction would be mu into n. Now what is n here? We have n plus F sin theta equal to mg. I'll write it as mg. N plus F sin theta equal to how much? Mg. So what is n equal to? N equal to mg minus F sin theta. So in that case, what will be frictional force? Frictional force would be equal to mu into mg minus F sin theta. Now if the object is moving, then the acceleration of the object would be applied force, that is F cos theta, minus frictional force by m. So the acceleration would be F cos theta minus frictional force is how much? Mu into mg minus F sin theta by m. So this is how we find acceleration when force is applied at an angle to the horizontal. Now let's look at frictional force in case of an inclined plane. Now when an object is placed on an inclined plane, we can see that normal reaction is equal to how much? Normal reaction is equal to mg cos theta. So what will be frictional force? Frictional force would be equal to mu into n. So that is equal to mu into mg cos theta. So if the object is sliding down, then the friction will be acting up. Then acceleration can be given as mg sine theta minus mu mg cos theta, right, by m. So what will be the acceleration? That will be g sine theta minus mu g cos theta, right? Now again, if a force F is applied in the upward direction and object is moving up, in that case what will happen? The expression for acceleration would be applied force minus mg sine theta minus mu mg cos theta, because both mg sine theta and frictional force will be acting downwards, right, if F is applied parallel to the surface, upwards, right, parallel to parallel to incline. So in that case, this is how we get it. So the direction of friction depends on the motion of the object, and the direction of friction would be opposite to motion if the object is having relative motion. Now if it is a vertical surface, how does friction come into picture? I'm pushing, let's say I'm pushing with the force F. So if I'm pushing with the force F, normal reaction would be equal to how much? Normal reaction would also be equal to F. Now the weight that is acting downwards is mg, and the friction would act is upwards is F. Now if the block is not sliding down, it's a static case. So in that case, what should happen? Mg should be equal to friction. Now what is friction? Friction is mu n. So I can have mg equal to mu n. So minimum value of mu for which the object doesn't slide down is mu equal to mg by n, that is equal to mg by f. If mu is less than that, what will happen? The friction, the object will slide down because weight would be greater than the maximum possible friction. So this is what is there under friction, the important points. The remaining things would be doing in the questions. So what all things we have seen? We have seen how what is friction. Now, how does friction come into picture? What is static friction? What is kinetic friction? And then how friction acts on horizontal surface, vertical surface, on inclined plane. Hope you could follow these things. Thank you very much.